Boom! An explosion of supersonic waves, interplanetary heat, dust, fumes. The Earth's atmosphere has been invaded by a cosmic rock the size of Everest. A few seconds ago, this rock, weighing trillions of tons, was hurtling towards Earth. It could fly from New York to Anchorage faster than you could fry yourself an omelet. This monster's name? The Chicxulub Incident. Epic name, right? 66 million years ago, it crashed into the Earth. Back then, dinosaurs ruled the planet, but not for long. The epic collision took place in modern Mexico, in the Yucatan Peninsula, right near Cancun, where the dinosaurs were vacationing. Well, probably not. Still, the huge space rock hit the ocean, but even all that water couldn't stop the inevitable. The collision caused a huge amount of energy to be released. The horror on a planetary scale had begun. Imagine a mini-sun lighting up the surface of the Earth with tsunamis the height of the Statue of Liberty bursting from the epicenter of the watery impact. Not good. The blast blew through the surface of the Earth. It was as hot as an oven and burnt everything in its path. The impact provoked a colossal earthquake and serious volcanic activity. A bunch of volcanoes simultaneously released hot lava and ash into the prehistoric skies. Millions of tons of ash and soot poisoned the air. This formed a huge ash cloud in the atmosphere, which blocked out the sun's rays for several years. The long winter had begun. Only there wasn't any snow falling from the sky, but rain made of sulfuric acid. Yes, the Chicxulub incident might just be the most important thing that ever happened in the history of our planet. Even more than YouTube. Back then, there were loads of volcanic eruptions, a lot of flammable oxygen in the atmosphere, constant temperature changes. It was the perfect and worst time for all of this to go down. So, how are we so sure about all this? Well, the asteroid left an absolutely huge crater on the planet's surface. Today, this scar is hidden under the Gulf of Mexico. Scientists found a lot of places on Earth with abnormally high levels of iridium. This metal is very rare on Earth, but it's in a lot of asteroids that scientists have examined. Scientists studied some 66 million-year-old rocks. In the layers of rock, they found dust, the same dust that comes from asteroids. This could only have happened if a huge asteroid had crashed into Earth. The catastrophe led to the extinction of not only the dinosaurs, but also the asteroid. It was so hot at the point of impact, part of the asteroid just disappeared. A lot of water vapor and carbon dioxide shot up into the atmosphere. But the biggest problem, sulfur. It got kicked up by the asteroid impact and flew up into the air. These tiny sulfur particles blocked out a lot of the sun's rays. Without the sun, a lot of plants disappeared and the climate eventually got colder. The immense heat turned stones into glass. Scientists call these things tektites. The energy of the impact threw them up into the skies. After a short flight, the tektites fell down to Earth. But it wasn't pretty. Rain fell too, only instead of drops of water, you'd have seen hot glassy fireballs. They bombarded the planet's surface for days. The tektites set fire to everything. Scientists found evidence of this all over the world, not just near the collision site. But a lot of things from back then are still a mystery. Some scientists think that Chicxulub wasn't even an asteroid. It might have been a comet. Asteroids are mostly made of stone and metal. Most often they kind of look like a potato. A comet contains rock, metal, and ice. Comets look like dirty cosmic snowflakes, complete with ammonia, methane, and carbon dioxide. Comets sometimes come from the Oort cloud. It's a huge cloud of ice and debris around our solar system. From time to time, comets break free from the pack and head towards our sun. According to scientists, this special comet flew right past Jupiter. The gravity of that huge planet accelerated the comet even more. It flew towards the sun, gaining more and more speed. The comet's outer ice shield started to evaporate, and it probably gave off a lot of dust and gas, which made it look like it had a tail. The sun's gravity eventually shattered the comet apart. One of the fragments flew through space and crashed into the Earth 66 million years ago. So, asteroid or comet? The truth is, we'll never know. What we do know is that the Earth was seriously unlucky to be in its path, and it was never the same again. The catastrophe stopped the development of 75% of life on Earth. Some bigger marine animals, like crocodiles, turtles, and fish, survived the impact. Out of all land animals, the only ones to survive were the ones that were, on average, smaller than the modern raccoon. That includes a bunch of special species of dinosaurs, the ancient ancestors of birds. Scientists believe they survived for two reasons. After the huge impact, it took a long time for plants to start growing again, and a lot of animals didn't survive. Most remaining animals didn't have enough food. But these dinosaurs had a beak. With its help, they could split open nuts and dig seeds out of the soil, so they survived. The second reason is that these lucky guys had bigger brains. Some people think that they were able to cooperate with each other and quickly adapt to the new conditions. Other life forms survived too. Fungi and mold survived underground and underwater. Gradually, the darkness cleared away, and ferns began to take over the lifeless landscape. After a few thousand years, forests started to reappear. The animals that survived were pretty much all inconspicuous and small creatures. They lived in burrows, safe from all that hot ash. Before the collision, mammals had lived in the shadow of dinosaurs. But with all the dinosaurs suddenly gone, things were about to change. Mammals were able to take over. They began to dominate life, at least on land. Back to the moment when everything changed. Turns out, it wasn't the size of the asteroid that made it so powerful. It was more about the angle in which it hit the Earth. If the angle of impact had been different, the dinosaurs might have even survived the catastrophe. So, what would that have looked like? Well, let's travel back, way back. Oh no, there's a giant asteroid heading for Earth. Oh, wait, never mind, it missed. Whew. There are plenty of earthquakes, tsunamis, and volcanic eruptions every day, but dinosaurs don't mind that much. No big deal. Fast forward a few million years, and most of these ancient lizards have changed and are now unrecognizable. Thanks to a couple of ice ages, many dinosaurs are now totally covered with feathers to protect them from the cold. Mammals exist, but they're few and far between. You see a lot of bats in caves. There are tons of rat-sized rodents in the forests. During the day, they hide in the undergrowth or in burrows. At night, they go out in search of food. There are no horses, no elephants, or other large mammals. Why become large and eatable when there are so many dangerous reptiles with huge fangs around? There are no whales in the sea. Parrots, hawks, and pigeons are nowhere to be seen. But pterodactyls 2.0 whiz past you constantly. Some are about the size of a helicopter, while others are no larger than a swan. There are plenty of primates, but they're in no hurry to climb down from their trees and walk on two legs. No venturing out into the savannah, no evolution into Homo sapiens. In this alternate reality, open spaces are very dangerous. But then again, so are forests and trees. Nowhere is safe. To get some delicious primate treats, many smaller dinosaurs learned to climb trees. This was already happening back in the Cretaceous period, right before that huge asteroid just missed Earth. Whew, that would have been an epic collision. Dinosaurs have grown wiser since that near miss. Some are even as smart as a modern chicken. A large brain uses a lot of energy, and that's not always a good strategy for survival. Safer to keep brains small and keep making those teeth bigger and pointier. From tiny critters to colossal creatures, all animals are trying to escape from a wall of fire moving in their direction. The temperature is rising, and everything around starts catching fire. Soon, lots of animals and plants on Earth will cease to exist. This is the aftermath of a giant asteroid crashing into our planet. But what if dinosaurs had had critical thinking skills? They could have guessed what was going to happen, because this asteroid was visible a year before the impact. 1 year before the impact. With no city lights, all bright spots in the sky are stars. Some of them are planets reflecting the light coming from the sun, like Mars. But one of these dots is the asteroid. Later, it's going to be known as Chicxulub Impactor. It got this name because of the region of modern-day Mexico where it fell. Anyway, at this point, the asteroid looks like a star. It has the same brightness as Neptune. You could even have photographed it with a high-quality camera. If only dinosaurs had thumbs. The impactor is now passing through Jupiter's orbit. From this distance, Earth looks like a pale blue dot. 1 month before impact. The asteroid has become much brighter. It's now the most brilliant spot in the night sky after the Moon. The asteroid crosses the orbit of Mars. Its tail, consisting of dust and gas, is getting longer and longer. It's now as long as 2 times the distance from Earth to the Moon. 1 week before the impact. The intruder's tail is now 5 times the distance from the Earth to the Moon, but the dinosaurs can't appreciate its beauty. To them, it's just another bright dot in the night sky. If this asteroid were flying toward Earth right now, scientists could pinpoint the exact location of its impact within a mile. Then we would evacuate people from the impact area and avoid a major catastrophe. 1 day before the impact. The Chicxulub Impactor now holds first place among the brightest objects in the sky. The light surrounding it, called the halo, seems even bigger than the Moon itself. The asteroid is now passing through the Moon's orbit. It looks like a bright spot that leaves an ashy trail behind it. 1 hour before the impact. The light from the Chicxulub Impactor is brighter than the full Moon, and its movement can be seen with the unaided eye. Nights on Earth aren't dark anymore. Only now, dinosaurs begin to feel anxious. All animals on Earth start to seek shelter. 10 minutes before the impact. The asteroid is now passing through Earth's orbit. Thousands of small fragments from its tail begin to fall on the planet. It looks like a meteor shower. So far, these fragments are too small. They all burn up in the atmosphere before reaching the surface of the planet. The asteroid is approaching South America. If someone was looking at it from Europe, it looked like a sunset. The bright dot of the Chicxulub Impactor is falling behind the horizon. 2 minutes before the impact. Dinosaurs can now easily see the asteroid's shape. If they knew how to do it, they could even estimate its size. It's a bit more than 6 miles across, which means it's almost the size of Manhattan Island, and the giant's weight is 15 plus 15 zeros pounds. It's flying toward the Yucatan Peninsula at a mind-boggling 7.5 miles per second. At that speed, you could get from New York to Los Angeles in around 10 minutes, but you'd kind of burn up on the way. 10 seconds before the impact. The Chicxulub Impactor is now approaching the ground. A few more feet and bam! The night sky suddenly turns white. The flash is so bright that the sun isn't visible at this point. The asteroid's entry causes a powerful blast that can be heard on the other side of the world. The huge asteroid begins to burn because of friction with the air. It heats up and splits into many pieces. These pieces shower on Earth. After a few seconds, the largest part of the meteorite hits the ground. Its mass and speed provide the Chicxulub Impactor with an enormous amount of energy. In the next moment, a super powerful explosion shakes the ground. The blast wave from the meteorite begins to spread out from the impact site. It rips out huge chunks of soil and trees and then pushes them to the ground like dominoes. The temperature of the blast wave is so high that everything around the impact site catches fire. The energy released during the collision also penetrates deep into the planet. This causes the strongest earthquakes in our planet's history. They, in turn, generate tsunami waves as high as the Empire State Building. 5 minutes after the impact. The meteorite leaves behind a huge crater. It's as wide as Lake Huron and deep enough to fit inside 2.5 Mount Everests. Dinosaurs are running around in panic. They try to evacuate toward North America, but most of them don't make it through unfamiliar swampy territories. Another danger is the ongoing meteor shower. Hundreds of tons of ash and debris rise into the air. Heated up by high temperatures, they fall to Earth in the form of liquid lava. Ash and smoke fill the atmosphere and block the sun's rays. Earth plunges into darkness. For several more weeks, our planet will be totally dark. Acid rains will fall on its surface non-stop. There was a lot of sulfur in underground deposits on the Yucatan Peninsula. The energy of the explosion evaporated all this sulfur. Now it's cooling in the air, gathering in clouds, and dripping to the ground. Most animals survive the impact, but the mass extinction continues for many more months. The collision has plunged Earth into darkness. and this has wiped out most of the plants that fed on sunlight. The plant-eating dinosaurs have lost their main food source and begin to disappear. But plant-eating dinosaurs are the main diet of meat-eaters, and now dinosaurs like T-Rex have nothing to eat. Soon, they go extinct too. In other words, it wasn't a meteorite that wiped out dinosaurs, but hunger and climate change. Meteorites of this size fall once every 100 million years. It means that such an event might happen again. Will humans manage to survive this disaster? These days, we can look out far into space, and the appearance of an asteroid the size of the Chicxulub impactor won't be a surprise to astronomers. In general, asteroids that are more than 460 feet across are considered potentially dangerous. Anyway, if we know about the approaching space body, we'll be able to build shelters filled with food and water supplies. Once the asteroid is close enough, we can wait for the impact and its consequences inside. But when people come back to the surface, they'll see cities and towns torn down. Our planet will look like a lifeless desert. That's why we need another alternative, which is to prevent the impact. Here, we have many options depending on the size and material of the asteroid. According to NASA, the most effective way is a kinetic ram. We'll need to send a fairly large and heavy object, such as a spaceship, into space. When it approaches the asteroid, scientists will choose the perfect trajectory, and the ship will crash into the space body. A powerful collision will change the asteroid's course, making it fly past Earth. The further this space body is from our planet, the easier it'll be to send it away. Another option is a controlled explosion on the surface of the asteroid. Newton's first law of motion will help us here. It says if a body is moving at a constant speed in a straight line, it will keep moving that way unless it is acted upon by a force. So, if we make a big enough explosion or force, the asteroid will shift its trajectory. How much it moves depends on the amount of force applied to it. We can also blast the asteroid right from inside. In this case, there will be no need to change its trajectory. Instead, we'll try to turn one huge hunk of rock into a bunch of smaller fragments. They will burn up in the atmosphere and do no harm to our planet. Another way is a gravity tug. Every heavy object has its own gravitational force and gravitational field. Our goal will be to send a spacecraft to the asteroid and make it fly close to the intruder. The asteroid will attract the spaceship, but its engines will resist. As a result, the ship will slowly but surely pull the asteroid toward itself. This method will take much longer, but gradually, the trajectory of the asteroid will change and it won't crash into Earth. Hopefully. We can also use solar power. We can build a spaceship with a system of giant magnifying lenses. Then we'll send that station closer to the Sun. When we spot an asteroid, we'll point the lens in its direction and focus the beam on the space body. The heat from the Sun will cause the asteroid's material to evaporate. Eventually, this will make the intruder change its trajectory.
The problem with that asteroid that destroyed dinosaurs was not that it fell, but where it fell. This colossal space rock found the worst place where it could land. Also, the angle at which it hit the ground was the most unfortunate. If it had fallen vertically, there would have been less destruction. But it fell at such an angle that it threw a huge amount of dust into the air. After the disaster occurred, tons of soot started burning. 65 million years ago, only 13% of Earth's surface contained the right amount of sulfur and oil needed to form a colossal amount of soot. If the asteroid had fallen on the other 87% of the territory, dinosaurs could still be living today, but it hit the worst place and lifted 1 million tons of burning material into the sky. A cloud of incandescent particles covered the sky and set off on a journey across the mainland. Then, these particles settled on the ground and caused large-scale fires. Trees were burning and sending more soot into the sky. But the asteroid collided not only with rocks, it fell on the coast in a place where the seabed was filled with sulfate. As a result of the collision, it started burning, which caused the release of sulfuric acid into the atmosphere. The air became poisoned. It seems the dinosaurs didn't stand a chance. And now, let's imagine the asteroid falling in another place, somewhere in the middle of the ocean. Huge waves flooded part of the land, but almost all kinds of dinosaurs survived. Or even better, the rock could have fallen somewhere in the desert and left behind a giant crater. That's all. Yes, several dinosaurs passing by wouldn't have survived the collision, but the situation wouldn't have been so critical in general. So, giant lizards remain dominant on our planet. They don't allow other animals to develop since Tyrannosaurus and other ferocious reptiles hunt mammoths and other ancient creatures. The population of mammals is decreasing. Velociraptors are fighting for territories with saber-toothed tigers and giant bears. A struggle for survival between dinosaurs and other animals begins. Then, the Ice Age comes, and some reptiles don't survive. Then, new players enter the field. Those are humans' early ancestors. Living side by side with dinosaurs is difficult. Lizards attack settlements and caves, so people have to build high walls for protection. By the way, the Tyrannosaurus poses less danger to people than you might have thought. According to the latest research, many creatures were able to run away from this monster. Yes, you probably saw how easily they caught up with cars in the movies, but it wouldn't be as scary in reality. Paleontologists and biologists have analyzed the strength of dino's bones and found out that the creature couldn't reach high speeds. The maximum it was capable of was running twice as slow as a field athlete. Thousands of years have passed. People have learned to live with dinosaurs. They've even managed to tame some lizards. They've domesticated herbivorous dinosaurs to develop agriculture. Triceratopses and bulls now plow fields together. Imagine farms swarming with diplodocuses or brachiosauruses. People climb their long necks and pick fruit from high trees. Stegosauruses protect pastures from wolves and velociraptors. Dinosaurs with shells, such as ankylosauruses, help people cross deserts. They, along with camels and donkeys, carry heavy loads. People share the planet with ancient lizards and live in harmony. The situation in the seas and oceans is much worse. Sea reptiles attack wooden ships and catch all the fish. Imagine that you're sailing to another continent with tons of grain, fabrics, fur, and other goods. And then a giant mosasaur appears on the horizon. It's one of the most powerful sea lizards. A great white shark looks like a small fish next to it. The creature could easily defeat a megalodon. And then it comes across a wooden ship. It bites into the deck and pulls the whole boat underwater. Water dinosaurs are the main obstacle to communication between countries. This slows the progress down for 100 years. People built metal ships to withstand the attacks of the mosasaur. And finally, they managed to establish sea connections. A similar problem occurs when the first planes take off into the sky. Imagine you're flying on a passenger Boeing. You look out of the window and see a pterodactyl. Wait, it's impossible. These winged lizards aren't so fast, but they can catch up with a helicopter or some old biplanes. This poses a serious threat to flights, so people install sound protection systems on board each aircraft. Pterodactyls hear irritating ultrasound from a distance and fly as far away from it as possible. People equip submarines and ships with the same sound shields. Then, after people have learned how to defend themselves from dinosaurs, another problem appears. Lizards are the kings of wildlife, so they displace all other animal species. Dinosaurs run across African savannas, and lizards with fur live in cold winter forests. Lions, wolves, and bears are not the rulers of the wild. Rhinos fight with Parasaurolophuses. Stegosauruses attack hippos and take away their territories. Venomous dinosaurs live in jungles. Lizards that can climb trees scare monkeys. Imagine a reptilian ape jumping from one branch to another. To save regular animals from extinction, people have to control the population of predatory reptiles. Huge parks and nature reserves appear in all countries. People transport dinosaurs there and separate them from other wildlife. Dinosaurs seem to be completely under control. When the danger caused by giant reptiles passes, people begin to breed smaller, harmless lizards. Someone buys a chameleon, and someone keeps a Microceratus at home. There are dinosaur exhibitions. People take these creatures for a walk as if they were dogs. Some people take selfies with reptiles, go shopping, and sit in cafes with small lizards. Dinosaurs aren't formidable now. They're kinda cute. People ride horses, camels, Parasaurolophuses, and Pachycephalosauruses. Of course, many have tried to tame velociraptors, but failed. Those are dangerous reptiles and they don't know how to obey. Taming them is almost as difficult as taming an alligator. But dogs and cats are still more popular because they're more intelligent. The brain of a dinosaur is almost the same as that of a chicken. But who knows, if they had lived to this day, perhaps they would have evolved into smarter creatures. Just imagine if dinos were intelligent. In this case, people would have a big problem. Some scientists think that even if a meteorite hadn't destroyed the dinosaurs, they wouldn't have survived to this day. They needed to carry their own colossal weight at all times. It was an enormous load on their bones and joints. Most dinosaurs wouldn't have been able to survive the Ice Age with such characteristics, but smaller lizards might have succeeded. Fast and agile dinosaurs, such as velociraptors and pachycephalosauruses, would have survived, but in what form? Could dinosaurs have already evolved into something else? Look at the good old chicken. Many scientists believe it's a direct descendant of the formidable Tyrannosaurus. Somewhere deep inside the bird's DNA, there are genes that the dinosaur had. Yep, it's hard to believe, but look at the chicken's body structure and how it walks. Remove the plumage, cover the creature with scales, and give it toothy jaws instead of a beak. And now, you have a mini T-Rex in the coop. And by the way, not only chickens might be the relatives of giant lizards, many birds are dinosaurs' living descendants. Surprisingly, alligators, snakes, crocodiles, and monitor lizards are not as close to ancient reptiles as pelicans, storks, and other flying creatures. Over millions of years of evolution, the paws of dinosaurs turned into wings, and toothy elongated jaws ended up as beaks. The genetics of birds is the key to understanding dinosaurs. Pelicans are similar to pterodactyls, ostriches to velociraptors. Perhaps many other animals also share some genes with ancient lizards. If the meteorite hadn't fallen, all dinosaurs would have evolved into completely different, unusual creatures. Scientists want to carefully study the DNA of birds and try to reverse evolution with the help of genetic engineering. They hope to breed dinosaurs out of eggs one day. But to do this, they need to find a specific genome that hasn't changed over tens of millions of years. It hides in the DNA. And it's not so easy to find it and extract it. Do you think we will see powerful reptiles by 2050?
Traveling back in time now, this used to be hard. We fly past the Middle Ages, the first human civilization, the ancient ancestors of the first humans, the dinosaurs, the first land animals, the ancient sea creatures, and so on to the very beginning of all time. And there it is. This nebula is our solar system. Right now, it's just a cloud of multicolored dust made of hydrogen and helium spinning around. This cloud has begun to shrink and become denser. There's a theory that there were supernova explosions near our nebula. Their shockwaves squeezed the nebula from different sides until the center of the cloud became too heavy. The enormous weight presses it, and nuclear chain reactions begin at the very center of this cloud. It heats the cloud and makes it glow. Soon it forms into a dense sphere, and that's how our sun is born. It happened about 4.5 billion years ago. Our planet doesn't exist yet. There's only a disk of dust and space debris orbiting the young sun. These pieces of debris are fusing gradually and getting heavier and heavier. Let's look at the very center of this pile of asteroids. The total weight of the debris compresses the central region so much that a dense metallic core is forming there. The enormous pressure heats the core, and the temperature at the center of the young Earth reaches nearly 10,800 degrees. And there's a liquid core around the solid one. It creates the magnetic field of our planet. Now, when radiation from the sun and the solar wind reaches Earth, it smashes into a shield in the form of our magnetic field. So far, our planet is burning and looks more like a ball of lava. But it begins to cool down, forming a solid crust. At this point, another protoplanet appears on the horizon. It looks more like an asteroid, the size of Mars, and this massive piece of debris flies towards us. It hits the young Earth at such an angle that it knocks a part of our planet outward. The debris itself breaks into several pieces and stops in our orbit. After a while, all of this debris comes together to form the Moon. As a result of this collision, the Earth began rotating too fast. A day now lasts about 5 hours instead of the usual 24. But the Moon is heavy enough to slow our planet's rotation with gravity. Now, the Earth doesn't look like a hospitable place. The gravitational forces of the Moon are penetrating deep into the Earth and causing more volcanic activity. Also, meteorites are constantly falling here, causing frequent explosions on the surface. Ow! The gas that comes out of the volcanoes forms our atmosphere. The ice that was brought to our planet on meteorites evaporates. The vapor rises and turns into rain. This rainwater falls to the surface, cooling the hot lava and forming the first lakes and rivers. For several 100 million more years, Earth resembles the surface of Venus. It's a lifeless place with a bunch of volcanoes, acid rains, and no oxygen to breathe. The sun wasn't as bright as it is now. Plus, the sun's rays could barely pass through tons of volcanic dust in the atmosphere. But about 3.5 billion years ago, the first life appears here in the form of single-celled organisms that didn't need oxygen. They appeared in the shallow, warm parts of the ocean near the shore. These bacteria reigned on Earth for nearly 2 billion years throughout the Archean eon. They left stromatolites. These are stone pillars at the bottom of shallow warm water. They're the product of simple organisms and bacteria. These bacteria evolved until they learned photosynthesis. Bacteria began to produce oxygen by absorbing the energy of sunlight. At first, this oxygen was spent on oxidizing rocks, but then excess oxygen began to fill the atmosphere. Plus, at this time, the first algae appeared, which also produced oxygen. This event is called the Great Oxidation Event, good name, which caused almost all living organisms to disappear from the face of the Earth. For simple organisms, oxygen was toxic, and the remains of bacteria and microorganisms sank to the bottom of the ocean. Many millions of years later, these remains will be recycled, and under the tremendous pressure of water and the Earth's crust, they will turn into oil. The Archean eon ended with this catastrophe about 2.5 billion years ago. At the same time, continents were forming on Earth, which would later drift through the world's oceans like puzzles and form a supercontinent. But for now, methane and carbon dioxide still make up most of the atmosphere. They cause the greenhouse effect and the rising temperatures on Earth. But the emergence of oxygen stops the greenhouse effect, and the temperature on our planet drops. An ice age, the so-called Huronian glaciation, which lasted from 2.4 to 2.1 billion years ago, begins. Scientists speculate that our planet was almost completely covered in ice at that time, even on the hot equator. A huge change when you consider that 2 billion years ago, our planet was like a ball and lava, but now it's like a block of ice. Earth, during the Huronian glaciation, was more like Jupiter's satellite Europa. There, too, is a thick crust of ice, under which there's a liquid ocean heated by the core. The evolution of the Sun saved our planet. Since its birth 4.5 billion years ago, it's been getting bigger and hotter. So, after 300 million years of an ice age, the Earth began to warm up. But almost all life there had been wiped out, and evolution has to start all over again. About 1 billion years ago, all of the continents of our planet were assembled into one hypothesized supercontinent, Rodinia, and all the oceans made up one colossal ocean of Miravia. 750 million years ago, that continent broke apart and huge chunks of land began drifting across the planet. Complex plants and multicellular organisms appeared just at this time. Algae, sponges, and fungi weren't the only inhabitants of the ocean. This is Sprigina. They're a kind of worms the size of a human finger. We have remains of these animals that are at least about 550 million years old. 541 million years ago, the Phanerozoic eon began. The main event at that time is the Cambrian explosion. Life began to blossom on Earth, and a great variety of living organisms appeared. Mollusks and echinoderms like starfish and sea urchins appeared. Living organisms evolved, having not only an internal but also an external skeleton, like trilobites. Some of these things could reach nearly 3 feet in length. Their protective shells suggest that there were predators in the ocean. A food chain started forming at that time. At the same moment, the drifting continents fused again. This supercontinent has a different shape and is called Pannotia. Later, these continents drifted apart again and began to collide with each other. This led to the formation of mountain ranges. Then the continents met for the last time and formed the giant supercontinent Pangaea about 335 million years ago. Here we can already see the outline of the modern continents of Africa, North and South America, Australia, and Eurasia. One of the largest sea creatures ever, the Dunkleosaurus, appeared. Some individuals could be as long as a school bus and weigh as much as a large SUV. The land had a hot and humid climate. It encouraged ferns and other plants to grow faster. Some of them could reach the height of a 3-story building. And for the first time in Earth's history, some animals leave the ocean and go on lands, such as L. generpeton and Ichthyostega. Anyway, at first, they live only on the coast because their skin wasn't adapted to the constant sunlight. In addition, they experience breathing problems. The first animals on land had both gills and lungs, but the lungs were underdeveloped, so they had to return to the water. Millions of years later, these animals evolved into more advanced amphibians. Though they were no bigger than ordinary lizards, they could already live fully on land. But this blossoming of life ended in a new ice age. Glaciers from the poles slowly crept toward the equator. Animals weren't prepared for this, and most of them didn't survive this extinction event. But 290 million years ago, evolution retook hold and more evolved land animals began to appear. Gradually, they increased in size, multiplied, and gave birth to a new species like Scutosaurus and Gorgonopsis. But this period didn't last long either. Only 40 million years later, as a result of unknown events, 95% of all living organisms on Earth ceased to exist. It could have been caused by a giant meteorite or by increased volcanic activity. Also, one hypothesis says it could have been the release of methane from the bottom of the ocean. The Mesozoic era began after this extinction. This is where the dinosaurs, as we know them, appeared and started a new page in Earth's history. Big herds of dinosaurs run through the forest. The temperature rises rapidly, and everything behind them begins to ignite. Some dinosaurs get stuck in swamps and can't get out. Pterodactyls fly over their heads as they try to avoid the blast wave that will soon cover the Earth. This event happened about 66 million years ago. It wiped out almost every living thing on Earth. Birds and flying dinosaurs were just about the only ones who could survive the most massive extinction event ever. Hey, don't blame me, I wasn't around then. Let's go down their evolutionary tree to look at the world's first bird, Archaeopteryx. It was about the size of a modern raven, but it looked like a small dinosaur with feathers. It had many small conical teeth, almost like alligators. It's because Archaeopteryx was closer to reptiles than to birds. However, its brain was 3 times larger than that of these reptiles. Although it had wings with feathers, it could hardly fly like modern birds. Its shoulder joints didn't allow it to lift its wings above its back, so it couldn't make a full wing beat. Most likely, Archaeopteryx was capable of gliding flights with small wing flaps. Evolution has led to more evolved species capable of full flight. Pterodactyls. These guys had no feathers, but membranes made of skin and muscle. Its wingspan was about the length of a human leg. It could fly perfectly and catch fish and small animals. Although flying dinosaurs could easily outrun terrestrial predators like velociraptors and T-Rexes, most of them didn't make it through the impact of a giant meteorite. Let's look at this event step by step to see how they got to our time. 10 minutes before the meteorite crash. A massive rock about the size of Manhattan Island is moving towards Earth in space. It weighs 460 trillion tons. That's like 3 trillion blue whales, the heaviest mammals that ever lived on Earth, and it's approaching our planet at 12 miles per second. At that speed, it could cross the Atlantic Ocean in just 4.5 minutes. That's twice as fast as our modern spacecraft could fly. 5 seconds before the meteorite crash. Ooh, this is getting tense. The Earth's gravitational force continues to pull the giant meteorite. It blows a hole in our atmosphere and creates a popping sound so loud you could hear it on the other side of our planet. All the animals on our planet wake up in a panic. They lift their heads up and see a huge rock that begins to burn through the air. Smaller fragments start to break away from the main meteorite. This fire is so bright that it shines almost like the sun. Flying dinosaurs and other ancestors of modern birds are the first to sense danger. They make a beeline to the sky and try to fly as far away from the impact site as possible to save their lives. The moment of impact. The colossal mass and velocity of the meteorite give it an enormous amount of energy. As soon as it touches the Earth, it causes an explosion of 150 trillion tons of TNT. The blast wave literally rips out chunks of our planet and throws them up. A huge wall of energy begins to move from the point of impact in all directions. It snatches the trees out with their roots and pushes them to the ground like dominoes. The shockwave completely wraps around our planet. This energy turns into heat. Everything around the impact site begins to ignite. Green jungles and trees turn into smoldering charcoal in seconds. The ground and rocks simply evaporate. The collision caused a massive earthquake. Some dinosaurs may have fallen into cracks that appeared in the ground. A strong earthquake caused a tsunami, with waves higher than the Empire State Building. Dinosaurs that weren't trapped in the burning forest were washed away by the enormous waves. The dinosaurs of North America tried to escape by running to the north, but the blast wave inevitably catches up with them. Flying dinosaurs have no problem with earthquakes or tsunamis. They fly high enough to avoid the giant waves, but they will have to contend with continuously falling meteorite debris. 5 minutes after the meteorite crash. A meteor shower of giant rock fragments continues to fall to Earth. Some meteorites were the size of a car, others were more like a large building. Ashes and dust rise into the air. Their temperature is so high that they melt and turn into liquid lava and then fall back to Earth, causing more fires. Meteor showers cause trouble for flying dinosaurs too. They have to maneuver and dodge the falling red-hot rocks. The high temperatures are a huge problem for them because it might make them lose feathers. With no feathers, they aren't able to fly. 10 hours after the meteorite crash. The dinosaurs continuously ran north all this time. They found themselves in unfamiliar territory with many swamps. Giant dinosaurs like T-Rexes have legs as long as an adult human's height. They have a chance to get through this terrain, but if they fell, they could never get back up. The smaller dinosaurs, like Triceratops, had short legs and couldn't go through the dense swamps. 1 month after the meteorite crash. 15 trillion tons of ash were ejected into our atmosphere. A dark cloud blocked the sun, and the Earth was immersed in complete darkness. Surviving plants couldn't feed on the sun's energy and stopped producing oxygen. Surviving dinosaurs could hardly breathe because of the lack of air and a large amount of dust. The lack of sunshine in the sky made phytoplankton disappear. Many marine animals were left without their only source of food. The dust and ashes in the atmosphere prevent our planet from getting heat from the sun, and the temperature here is beginning to drop. The place where the meteorite fell was rich in sulfur. This toxic acid evaporated at the time of the impact and formed in clouds. Now there are acid rains on Earth. Flying dinosaurs now have to hide from these rains. They have to stay in caves and can't go outside to get some food. So far, a large number of terrestrial and flying dinosaurs have survived. They come out to see the aftermath of the disaster. The site of the impact was in present-day Mexico, the Yucatan Peninsula. The Chicxulub crater is located here. It's about 93 miles wide, like half of all of Lake Michigan, and it's 12 miles deep. You could plunge the whole Mount Everest in there, and there would still be 6.5 miles of available space. It wasn't the impact itself that made the dinosaurs disappear. The fire destroyed most of the plants the herbivorous dinosaurs ate. With no food, their numbers dwindled rapidly. Predatory dinosaurs had nothing to eat either. Acid rain and the disappearance of phytoplankton threatened all marine life. Even though birds managed to avoid the blast waves and tsunami, they were short of food too. About 80% of all birds didn't make it to the end of the extinction event. The problem was that all of the forests on Earth were wiped out. Most birds would nest and live in trees. Besides that, the forests were always full of food, from all kinds of ants and termites to flying insects and small mice. So, only those species that lived on the ground and could fly well survived. Most likely, they fed on the seeds of small surviving plants. This habit made flying dinosaurs lose their teeth during evolution. Instead of jaws with a bunch of sharp teeth, they got long beaks to grab tiny seeds from the ground. Although Earth looks like a terrible place to live now, there's an evolutionary boom for birds. They have to travel long distances in search of food. Their wings get stronger. They also feel safe from predators who regarded them as food before. No T-Rex now catches a sleeping bird off guard. About 1,000 years after the collision, the first dense forests appear. It gives another boost to evolution. 1 million years later, forests full of food are populated by the ancestors of modern mouse birds. And 65 million years later, in modern times, we have about 10,000 species of birds. Pigeons, crows, eagles, and hawks, even penguins. These are all descendants of the dinosaurs. But there were other survivors. Some alligator and crocodile ancestors were able to adapt to changing conditions. About 80% of turtle species managed to survive the mass extinction, and now their descendants live among us. Snakes and lizards were also able to wait out the hard times in their burrows. Even some mammals, like monotremes, survived. This hedgehog-sized animal was able to continue to evolve. Many millions of years later, these mammals evolved into primates, which later gave life to modern humans. Much, much later came the iPhone. They ruled the planet for over 170 million years and then disappeared. History says it was a huge city-sized asteroid that came from space and hit the land of the Yucatan Peninsula around 66 million years ago. It caused terrible environmental changes, debris in the air blocking the sunlight so the plants couldn't survive. Temperatures on Earth's surface plunged. The animals were struggling to survive until they finally went extinct. At least, that's something many paleontologists believe happened. Now, they found out dinosaurs were about to go extinct even before the asteroid. Their diversity started to go down 10 million years before the asteroid. Older, long-living species didn't evolve enough to adapt to all changes in the environment, such as higher sea levels, massive volcanic activity, cooler periods. Dinosaurs preferred a warm climate because it helped them to keep a stable body temperature. Dinosaurs lived on all 7 continents, even in Antarctica. That's because it wasn't all ice back then. Around 90 million years ago, Antarctica was a swampy rainforest with a warm, pleasant climate. It was even in a different location, only 560 miles from the then South Pole. That was the time of the warmest climate on our planet. The sea level was 560 feet higher than today, and the tropical sea surface could reach temperatures up to 95 degrees. Antarctica still had something like polar night, months without sunlight, but the climate around the South Pole was mild and temperate, with no ice masses. Dinosaurs didn't shed their skin in one long piece like today's reptiles do. Scientists believe they shed it in small pieces, had something like dinosaur fur. There was a dinosaur, Pagomastax, that looked like a cross between a porcupine and a parrot. It had 1-inch long jaws and ate plants. It had a short beak and self-sharpening long teeth. They were like scissors this small dinosaur used to slice up plants. Our modern lion has a mighty bite, but a big and scary T-Rex bites more than 2 times stronger. The king of the dinosaurs has the strongest bite amongst all land animals, 3.5 times stronger than today's record holder, the Australian saltwater crocodile. It also had the longest teeth, almost 10 inches long, the length of an iPad. Most modern animals are either warm-blooded or cold-blooded. Dinosaurs were somewhere in between. Scientists think they mainly were mesotherms, which means the activity of their muscles could warm their bodies, but their body temperature could fluctuate too. Many dinosaurs, such as Triceratops and Stegosaurus, had spikes, plates, horns, crests, or other bizarre structures on their bodies. In the beginning, scientists thought that's for things like defense. They had neither sharp teeth nor hooked claws on the toes to hunt. But soon, they expanded the theory. It was probably a way to impress their mates and identify members of their kind. One species, namely Pachycephalosaurus, even had a funky bone hat on top of its head. Scary, tall as buildings, massive. That's what we saw in the movies, but dinosaurs mainly were human-sized or even smaller. Bigger bones were easy to be fossilized, so that's why we mostly find gigantic species. Eoraptor, or dawn stealer, was the first named dinosaur. Small and toothy, like me, it got its name because it comes from the dawn of the dinosaur age, the size of a German shepherd, but probably not that friendly. Arched back, sharp bony plates, curved tail. Ankylosaurus were some sort of giant, much-spikier dinosaur version of an armadillo. Its weak spot was a soft underbelly, but meat-eating dinos that were after this one had to flip that guy first to get there. Still, it was really tough because of their impressive gear. Scientists believe they even had bony eyelids. Some dinos ate meat, others plants, and some of them could nibble even on pebbles. One dinosaur, called Gallimimus, couldn't physically chew all those plants it ate, so it would ingest pebbles to mash up the food. Gallimimus looked like some weird alien mix of dinosaur and bird. But it couldn't dribble a basketball because its wrists weren't capable of keeping the palms parallel to the floor. And they had no three-point shot. The largest dinos were plant eaters. Meat eaters, or so-called theropods, were mostly smaller. One reason is that plant-eating dinosaurs were very greedy. They would devour enormous amounts of food, sometimes even swallowing the entire branches without chewing. Some of the biggest could eat a ton of food every day, like a bus-sized pile. There were also more plant-eating dinosaurs than the other ones. Scientists are still not sure if meat-eating dinosaurs were able to coordinate themselves in hunting groups. They were probably unfriendly towards each other, especially when it comes to sharing prey. Fossils and the shape of delicate bones in the eye tell dinosaurs mostly roamed around during the day. Scientists think only smaller meat-eating dinos, like Velociraptor, were active during the night. They were after those small mammals snuffling around and trying to find food while big dinosaurs were asleep, or that's what they thought. Those small mammals were usually burrowing animals that survived both dinosaur reign and ice age hiding underground. Not all mammals were hiding from dinosaurs. Some small but sneaky creatures, like Reptinomammus, would steal the eggs from big dinosaurs, which was a big thing considering they had to trick the mama dinosaur first. Researchers believe dinos tried to flap on the ground to get faster at running up inclined terrains to catch their prey. Such behavior caused them to learn how to fly, which of course happened through thousands of years. Dinosaurs were fuzzy and fluffy. They are related to birds, but even those early dino species that didn't fly had feathers, like gigantic, scary, fuzzy T-Rex. Movies lied. You just can't stand still and expect a T-Rex would pass you by. Its vision was probably better than one today's raptors have. Even without it, they still had a pretty good sense of smell. Running could help it though. Scientists calculate T-Rex could probably run at 12 miles per hour. It would shatter its bones at a greater speed. Some dinos had tails more than 45 feet long. Tails helped them to keep their balance when running, especially those that walked on two legs. Velociraptors were not like raptors we see on the screen, but more like some sort of prehistoric chickens. Small, a little bit bigger than a turkey, 2 feet in height, probably had feathers, hollow bones just like birds, mostly loners. But they were probably among the smartest dinos. Their brain was big compared to their bodies. They were as intelligent as today's ostriches. The name Velociraptor means speedy thief. Stegosaurus had a pretty big body, spiky plates, and a tiny brain, the size of a walnut or lime. But at least it had its own air conditioner. Researchers found out its spikes were filled with veins that transferred blood and developed a theory that they were cooling its giant body that way. Dimorphodon was the flying reptile with a wingspan of 8 feet and multi-purpose teeth. Teeth in the upper jaw were longer, sharper, and better for catching food from the water. The teeth in the bottom jaw were better for holding the game in transit. One of the first potential dinosaur discoveries was in China 3,500 years ago. No one knew about dinosaurs then, so people thought teeth they found could belong to dragons. The Hadrosaurus was a duck-billed dino with more than 1,000 teeth. When they would fall off, it could grow new ones indefinitely. Dinosaurs' eggs were pretty big, some as big as beach balls. Now that's an omelet. The Baryonyx was a big fan of fish. Its name means a heavy claw, and it got it because of big extended claws that were pretty sharp and made up the thumb of each hand. When catching fish, they used the claws like spears. Mosasaurus, also popular in movies, was not quite the dinosaur but a marine lizard, closely related to monitor lizards and snakes. Like a snake, it had jaws that could expand when swallowing the food. These creatures were speedy. They had a tail fin and flipper-like paddles instead of arms and legs. Researchers believe they had a weak sense of smell and poor perception of depth, so they had to develop a unique hunting technique, waiting for their snack to come up to the surface for some air. Now, thanks to new fossil discoveries and technologies, we're getting to learn more and more about the biology of dinosaurs. Some people don't need to know more than the fact that a few of them were colossal, terrifying, and vicious. But for those of us that do, the use of comparative biology, pigment analysis, and powerful new X-rays have allowed us to gain insight into specific features, such as their colors, eating behaviors, and the shapes of their tongues. Yes, that's right, the shapes of their tongues, which, for a long period of time, was something of a mystery. This is because soft, fleshy dinosaur parts are hardly ever retained in fossil form. But thanks to the discovery of some surviving hyoid bones, which are situated at the root of the tongue in front of the neck, we now have some insight. Most animals have this hyoid bone that anchors the tongue. The shape and complexity of the bone determine how free-moving the tongue can be. Scientists have discovered that nearly all dinosaurs had simple tongues that laid flat and were extremely similar to the tongues found inside the mouth of a crocodile today. Yeah, this crocodile. Go ahead and take a closer look. Nah, just kidding. Come on back. Let's take a look at some specific dinosaurs and start with the Brachiosaurus. Let me stick my neck out on the line by guessing that most of you will be familiar with this dinosaur because of its neck. You know, the one which was typically 30 feet in length. Despite its neck being its most distinctive feature, its name actually translates to arm lizard in Greek. It's common knowledge that the Brachiosaurus is one of the largest dinosaurs to ever have lived. On average, it reached 76 feet in length and 40 feet in height. It's roughly the length of 2 school buses and as high as a 4-story building. None of which were around in the era of the big guy here. Fragmentary leg bones and vertebra of even larger dinosaur species are known, but these skeletal remains are too incomplete to determine their exact size. So this guy may have been the largest dinosaur ever. A renowned herbivore, thank goodness. The Brachiosaurus is thought to have eaten up to 880 pounds of dry plant matter every day. Most of this was made up of coniferous trees, ginkgos, and cycads. This target might have been hard to hit for this dinosaur, as researchers have learned that its teeth were spoon-shaped and not ideal for chewing food. This means that the creature would have swallowed vegetation whole, as its teeth were suited to stripping it but not breaking up large chunks of plants. This, along with the dinosaur's body shape, suggests that the Brachiosaurus would have liked to feed as quickly as possible. Dinos like these didn't always make use of their ability to strip towering trees when dining. The Brachiosaurus traveled in herds, moving to the next location once they had exhausted all of the local vegetation. And I mean all of the local vegetation, not just that which hung high on trees. It's likely that the creatures supplemented their diets with vegetation at lower levels, especially after they'd done a number on all the nearby trees. This method of feasting was the most energetically appealing for this giant. By munching on lower vegetation, researchers believe that the dinosaurs saved up to 80% in energy compared to when foraging for high-up food sources. They have also discovered that the nostrils of a Brachiosaurus were on the front of its face and not the top. This is because we now know they roamed the fertile floodplains in their respective herds. For decades, it was believed that these creatures lived in deep, watery swamps. Let's look at another common misconception about a popular dinosaur. Please put your hands together for the Tyrannosaurus rex, which is arguably the most famous of all dinosaurs. Discoveries from the past 100 years have revealed that theropods had heavily feathered skin. Theropods are the family of dinosaurs to which the T-Rex belongs, so naturally, people began to think that the creature would have been covered in feathers as well. However, a study from 2017 took skin impressions from the iconic dinosaur and found no evidence of the structures required to support feathers. If a T-Rex did have feathers, they would have been limited to its back. Researchers accept that other large dinosaurs of the same family as the T-Rex have been discovered with their remains covered in feathers. An example of this would be the Yutyrannus dinosaur. But as of now, the accepted theory is that feathers weren't a common feature of T-Rexes. This makes it easier to believe that feathers were exclusive to smaller tyrannosaurids and were there as a means of keeping the creature warm. For a long period of time, researchers thought feathers were an exclusive feature of the theropod family. But this theory has been debunked. Just like the kid at camp who was kicked out of the top bunk. You know, debunked. Anyway, fossil evidence discovered in Siberia now suggests that multiple different family groups of dinosaurs had feathers. The Siberian fossils in question belong to another species of dinosaur, Calindrodromeus zebucolicus. Oh, you think I mispronounced that? Okay, prove it. Now, this dinosaur, I'll call her Calinda, had a pelvis structure superficially similar to that of a bird and was roughly 4.5 feet long, about as tall as a fridge. Since the purpose of feathers on dinosaurs was for warmth, it's quite possible that dinosaurs from cold weather climates had more feathers than their counterparts in warm weather climates. In general, bigger animals struggle less with keeping themselves cool, so it's likely that any of the large dinosaurs who lived in these warm climates had no feathers at all. Smaller dinosaurs who lived in cold climates, on the contrary, had plenty of feathers. We now even understand what some of the designs and patterns of these feathers on dinosaurs looked like, thanks to the discovery of an ornithomimus, complete with feather and skin impressions. The name of this dinosaur is derived from Greek and actually translates to bird mimic. They were typically 11.5 feet in length, nearly as tall as a giraffe, and despite being omnivorous, had no teeth. Its other distinctive features included 3 fingers, which were all unusually the same size and length. And despite their thin bone skulls, they also had large brain cavities. Their legs were extremely long, in particular their foot bones. Combine this with their toothless beaks and long necks, and yep, it must have looked a lot like an ostrich. Although they're not as big as the Brachiosaurus or dinosaurs in general, they are bigger than any other bird in the world. And it wasn't just the body limbs of an ornithomimus that made it resemble an ostrich. They also had very similar feather patterns. Their heads, necks, and lower legs were mostly bare of feathers, but the rest of their bodies were well coated in downy plumage. This is what you call a bird's layer of feathers as a whole. It's possible, like an ostrich, that the dinosaur would have used this unusual feather pattern to regulate its body temperature. Despite some dinosaurs possessing feathers like birds, on top of also being their distant relatives, dinosaurs didn't have the type of feathers required to fly for most of their existence. Feathers found in fossil impressions or preserved in amber have allowed researchers to gain insight into why these creatures weren't very aerodynamic. The structure of these feathers appears to be very simple, with a poorly defined and flexible central shaft. These feathers would have better served any dinosaur as a fashion statement, as they would have helped attract the attention of other dinosaurs. These feathers also would have had the ability to regulate body temperature. Surprised to hear that dinosaurs had ostrich-like feathers? Wait till I tell you that their prehistoric distant reptile cousins had something that looked like fur. Allow me to introduce you to the pterosaur. Its name is derived from Greek and translates to winged lizard. Just like dinosaurs, they were initially thought to have scaly or leathery skin all over their bodies. But over the course of the 20th century, fossil examinations revealed that many parts of a pterosaur's body were furry. The wingspan of a pterosaur could reach the length of over 23 feet, about as long as a London bus. Its toothless jaw was very long and resembled that of a pelican. How could something that looks like a pelican be so terrifying? These creatures were coated in pycnofibers. Those were simple structures, feather-like in composition, but strand-like and fuzzy like fur. Further research suggests that some parts of the pterosaur's body had more complex kinds of feathers with branching strands. If this is accurate, it would be the first time feathers were found on an animal that was neither a dinosaur nor a bird. So your starship is flying through space at 99.9% of the speed of light. Hey, aren't you cool? The stars turn into bright, continuous lines. Infinite outer space has shrunk into a tunnel. A bright flash ahead. Boom! Starship shoots out of the tunnel like a cork. You see the ancient Earth. The computer says you went back 70 million years. You're a paleontologist of the future who traveled through time for one purpose: to see with your own eyes the most underappreciated dinosaur in history. You have come down to Earth and are walking through the jungle. Suddenly, you hear a mighty roar. There's a dinosaur coming out of the trees. It's more than twice your height and weighs as much as 4 cars. Scientists have found only 2 huge arms left of this dino. For 60 years, Dinosaurs has been a major mystery in paleontology. Now we can see this creature in its entirety. They managed to find a complete set of fossils in Mongolia. Translated from Latin, the name of this dinosaur means terrible hand. Apparently, this dino was lousy at playing poker. Dinosaurs is an animal cocktail that nature is prepared to make you both shriek and laugh. Let's take a look at it from the point of view of the evolution itself. First, we take the T-Rex. Dinosaurs and the king of the dinosaurs are about the same size. From the T-Rex, we'll only leave the powerful hind legs and the long tail. Instead of small forelimbs, we'll attach mighty 8-feet-long arms. And let's not forget about the fingers with razor-sharp claws. Each claw is as long as a kitchen knife. Then we add a hump like a camel's, a neck like an ostrich's, and a horse's head. And instead of a toothy mouth, we put a duckbill. Now our Dinosaurus is ready. It also has long and sharp claws on its flat feet. Such broad soles help it walk along the river bottom and not sink into the silt. Most scientists believe it was covered in feathers too. Plants were the main dish on this dinosaur's menu. To digest plant food, Dinosaurs swallowed stones. Many modern birds do the same. Stones in the stomach grind the tough plant fibers. In one of the Dinosauruses, scientists found 1,400 of those. Yes, this dino had a huge belly, which slowed it down a lot. With such a size, Dinosaurs lived for a very long time, 75 to 300 years, give or take. In a 100-million-year-old piece of amber, they found strange bones. They belong to the smallest dinosaur known to science. Take 2 paper bills from your wallet. This dino weighed the same. It was about the size of a modern hummingbird. Scientists don't know what the tiny dinosaur looked like more, a lizard or a bird, but they're pretty sure it could fly and hunted insects. Over 100 sharp teeth confirm that. What happens when you cross a chicken and a crocodile? You get one of these bad guys, a Hesperonychus. This dinosaur was small but had quite an attitude. It lived in North America and probably hunted mammals. It weighed only 4 pounds and was covered in feathers like a chicken. If the sloth was a dinosaur, it would look like a Suzhou lizard. It moved on 2 legs, was as tall as a modern giraffe, but weighed 3 times as much. Suzhou lizard had feathers on its body, and a long neck helped it look in all directions. Overall, the tail of this dinosaur made it look like a giant rat on 2 legs. When scientists first saw the fossils of this animal, they didn't believe they were real. The Hulscaraptor looks like a hybrid of a velociraptor and an ostrich, only this dino was the size of a goose. The creature's strong hind limbs confirmed that it could walk on land. The dinosaur hunted fish, diving underwater for its prey. Now, we're used to flying animals having 2 wings, but evolution loves to break the rules. The Microraptor had 4 wings. Strong feathers were attached to each of those. The dinosaur weighed no more than 2 pounds. Its feathers were black and shiny like a crow's. There are no birds on the planet that have 4 wings. That means they evolved from 2-winged dinosaurs. Microraptor was the dead-end branch of evolution that didn't give way to any new species of animals. It seems that this hard-to-pronounce guy, I'll give it a shot, Tanystrophus, was a dinosaur drawn for a cartoon. But it existed in reality and lived in the water. It weighed 300 pounds and was 20 feet long. Half of its body was a flexible neck the size of a green anaconda. Scientists don't know why the creature had such a long neck. Most likely the dinosaur used it to catch fish or play jump rope. Imagine that 66 million years ago, I wasn't around then, an asteroid didn't crash into our planet. The dinosaurs didn't disappear, and the mammals failed to dominate the Earth. This means the primates didn't evolve and remained in the trees. Who would have taken the place of primates in such a world? Many scientists believe it could be Troodon. The dinosaur had the largest brain relative to body size. It walked on 2 legs and was about the size of a human. Hypothetically, Troodon could evolve and become as intelligent as we humans are now. By the way, the smallest brain relative to body size belongs to Stegosaurus. It was the largest of the armored dinos. It was a plant eater, but its powerful tail and sharp spikes were feared by all hunters of the age. A Stegosaurus weighed almost 4 tons, but its brain was meh, not much larger than a hot dog. Pagomastax was no bigger than a domestic cat, and it ran wild and free in Africa 100 to 200 million years ago. Imagine a bipedal lizard that looks like a parrot, Pagomastax was covered both with feathers and porcupine-like quills. It had a beak, but two sharp fangs grew from the lower jaw. Still, the creature's scary appearance is deceiving. The dino ran fast and could bite hard, but it was a peaceful plant eater all the same. Now, this one, Linhenicus, lived 80 million years ago. It resembled an ostrich that weighed like a medium-sized parrot. It could run quickly and hunted insects. Instead of arms, this dinosaur grew two tiny fingers with claws on their ends. It's the only one-fingered dinosaur known to science. This strange creature was one of the ancestors of modern birds. Jeholopterus was a flying dinosaur, looking as if it came straight from a sci-fi movie. It looked like a cat with bat wings. The creature was feeding on insects, but there's another theory that it could feed like a mosquito. This dino landed on the backs of large dinosaurs and pierced their thick skin with sharp fangs. Now, this is a fairy tale unicorn. It's as white as snow, beautiful and graceful. And this is a Qingdao lizard, the real-life prototype of that horned horse. A bony horn more than 15 inches long grew on its head. Perhaps the horn helped float in the water, attract partners, or make different sounds. The fairy tale unicorn is definitely cuter than this prehistoric creature. Our next guy, Inostrancevia, resembled a cross between a lizard and a tiger. Imagine an animal that weighs as much as 5 wild boars, with the body length of a sedan. Limbs with sharp claws, fangs similar to those of a saber-toothed tiger, and powerful jaws. It was one of the most dangerous animals that roamed the planet Earth. It occupied a niche that today belongs to lions, tigers, and other large cats. Next, please. Epidexeturus. Now, this is a small dinosaur about the size of a pigeon. It couldn't fly, but it was one of the first dinos with feathers. They were different from those of modern birds, though. They weren't divided into separate threads, but were whole and resembled plant leaves. This big guy, Therizinosaurus, isn't only known for its strange appearance and size, although it was as tall as a 5-story building and weighed like an elephant. The giant was notorious for the largest claws on the planet. It was really a manicurist's nightmare. 2-inch-long scythes protruded from its fingers. Despite those horrific appendages, it ate plant food, chewing it with its small teeth. The humongous jaws were needed to pull leaves off of tall trees. Ouch! Hey, I'm growing here! Meet the largest animal that flew in the earthly sky, Quetzalcoatlus. Just imagine a creature with a wingspan almost the width of a basketball court. To lift such a machine, it needed to be lightweight, so it only weighed as much as a modern pig, with its wings looking like a thin membrane. They stretched from the bottom of the legs to the elongated fingers. Artists often depict this creature covered in feathers, but its body was actually coated with fibers similar to human and animal hair. Acrotholus is an unusual dinosaur that wore a cap made of hard bone. No, not a baseball cap. The creature was the size of a Labrador retriever dog, but not as friendly. It wouldn't run after a stick. Rather, it would rush and ram its hard head into the rival of the same species or a predator. 66 million years ago, I wasn't around then, a huge asteroid hit the Earth and triggered the mass extinction of almost all living creatures on the planet, including dinosaurs. Had the space object crashed somewhere else, some dinosaurs would have been able to survive and still live nowadays. According to some research, the asteroid had about 1 in 10 chances of wiping out the dinosaurs and other animals of that time. It was way more likely to just hit the ground without any strong destructive consequences. To understand how things could have turned out if the place of the collision had occurred elsewhere, we need to find out what happened that day and why the disaster turned out to be so devastating. This huge space rock fell into the coastal area of the Yucatan Peninsula in Mexico. This caused a chain reaction that triggered natural disasters around the world. The place the asteroid hit is called Chicxulub Crater. Now half of this area is underwater. The asteroid was about 7.5 miles in diameter and moving at a speed of 27,000 miles per hour. This rock, bigger than Everest, was rushing toward Earth faster than the speed of sound by almost 40 times. Wow. The energy released in the collision was as powerful as an explosion of about 10 billion atomic bombs, and the destructive force of the blast wave was just one of several disasters. The asteroid happened to fall in one of the worst possible places, and because of the way it fell, it threw a huge amount of dust into the air. Imagine you're jumping into the water like a professional athlete vertically, leaving hardly any splashes behind. And now think of how much water splashes when you jump into the pool like a cannonball. So the asteroid landed the cannonball way. The second disaster the asteroid provoked was soot burning. A small part of the Earth's surface consists of rocks. Only a tiny percentage of that part was rich in oil and sulfur back then. The asteroid burned and lifted so much soot into the air that it would be enough to fill an indoor baseball stadium. According to research, 65 million years ago, only 13% of the surface of the entire planet could have contained the necessary amount of organic material for the formation of such a volume of soot. That's why this place was considered the worst. If the catastrophe had happened on the territory of the other 87%, then dinosaurs would have been alive today. A huge cloud of soot and carbon dioxide rose into the air and covered the sun. The soot turned the sky gray and partially blocked sunlight. This led to a quick drop in temperatures almost all over the planet. It seemed like Earth was inside a gray veil. Many plants and animals couldn't survive the cold snap. Trees began to wither because of the lack of sun. The photosynthesis process was disrupted. The cold and withering of trees led to another catastrophe: global famine. Herbivores couldn't survive because they lost almost all of their food. Plants, flowers, and trees didn't manage to get through the catastrophe. These destructions spread far beyond the asteroid impact site. Hot dust particles, asteroid chunks, and small pieces of rocks settled to the ground across the continent and caused large-scale forest fires. Burning trees threw even more soot into the air, which made the situation even worse. The huge asteroid brought heavy metals with an increased level of toxicity from space. The melting of these substances during the collision provoked firestorms. The asteroid didn't only hit continental land but also water, which triggered a huge tsunami. But that's not the worst part. The seabed was filled with sulfate, and when the energy of the asteroid burned it, it provoked the release of sulfuric acid into the atmosphere. The acid cloud mixed with a cloud of soot and began to spread throughout the sky. Hot rock particles were falling to the ground like fire rain. An acid rain started because of sulfur. It lasted for almost several days and left no chance for the animals to survive. Acid rain made the water in rivers, lakes, and seas poisoned. The acid destroyed anything that couldn't burn. A part of the clouds went to wreck the land, and the other part, the ocean. This made the situation even worse, as sulfur droplets wiped out a huge amount of seaweed and phytoplankton. The ocean generates almost half of all oxygen reserves on our planet. Those days, the sea creatures living in its upper parts were destroyed. It wasn't the blast wave, but lack of sun, acid, darkness, and cold that became the main reasons for the extinction of dinosaurs. But even when some lizards escaped from fires and sulfur, they met the sea element. The asteroid impact caused large-scale tsunamis across the planet. The very first wave was around 1 mile in height. That's almost 3 times higher than the Empire State Building. Billions of gallons of water were moving at 90 miles per hour. A wave this strong could easily destroy half of New York today. The meteorite created a series of waves 52 feet high. Massive walls of water the size of 5-story buildings collapsed on the shore and demolished everything in their path. Lack of sunlight, temperature drop, acid and fire rains, reduced oxygen production, forest fires, giant tsunamis, and the explosive wave with the power of 1 billion atomic bombs. All this reduced the biological diversity of Earth by 75%. Yeah, that'll change your climate for sure. Giant asteroids used to hit Earth before, but they never caused such disasters all over the planet. What if this asteroid had fallen into another place, say a forest, far from water and mountainous terrain? This would have caused severe fires. A huge black cloud of ash would have risen into the sky and obscured the sun. But it would have unlikely generated acid or fire rains. Most of the species of the planet could have survived this catastrophe. What if the meteorite had fallen somewhere among the ice and snow? This would have provoked a rapid increase in temperature across the planet. Huge tsunamis would have sunk big tracts of land. However, ash and sulfur dioxide wouldn't have filled the sky. Acid rain wouldn't have hit the ocean. Many marine creatures could have survived and lived to this day. and dinosaurs far from the oceans wouldn't have noticed the meteorite fall at all. Probably the most terrible events would have occurred if a meteorite had fallen on an active volcano. This would have triggered the largest lava release in history. Destructive earthquakes would have begun, and the whole sky would have been covered with volcanic ash. What if the meteorite had hit some desert? It would have melted billions of tons of sand and turned it into glass. Just imagine glass dunes that heat our planet even more. And we could dig up the well-preserved remains of ancient lizards out of the glass. Anyway, there were many different possible catastrophic scenarios, and the worst of them came true for the dinosaurs. They are unlikely to return, although perhaps they can be reborn. Scientists were inspired by an idea from a famous Hollywood movie. They wanted to find a mosquito that got stuck in amber. They would extract dinosaur DNA from it. But there was a problem with this. The oldest DNA sample they managed to find was 1 million years old. Dinosaurs were extinct about 66 million years ago. Besides, DNA is a very fragile thing. The probability that it could have been preserved intact somewhere for so long is very small. So, instead of searching for this ancient dinosaur DNA, scientists decided to take DNA from the closest ancestors of these lizards, birds. Over millions of years of evolution, dinosaur paws could have turned into wings, and elongated mouths could have become beaks. Pelicans are very similar to pterodactyls, ostriches resemble velociraptors, and chickens are very much like T-Rex. Okay, let's just stop and imagine for a moment a chicken the size of a T-Rex.
Hey, you want a piece of me?
Now, the common chicken is recognized as the closest relative of the huge lizard. Remove the plumage from it, cover it with scales, give a toothy mouth instead of a beak, and attach a long tail. And you get a real mini Tyrannosaurus rex by body structure and movement. Deep in its DNA, there are similar genes that formidable predators have. With the help of genetic engineering, scientists plan to play with its DNA and try to reverse the evolution, which means breeding dinosaurs can become a reality. Well, that could come back to bite you.